We are Team AgroLumen from
University of Magdalena, Colombia, and this is
our video presentation for the IEEE Myosa event 5.0.
Did you know that Colombia is uniquely positioned for agricultural development?
Thanks to its vast climatic and geographical diversity, the country sustains a wide variety of crops like coffee, bananas, rice, and many more. According to the DANE, in the first quarter of 2024, the agricultural sector accounted for 9.7% of the national GDP. However, agriculture constantly faces threats that affect productivity, sustainability, and food security. One of the most significant is Spodoptera frugiperda, also known as the fall armyworm, considered one of the most destructive and invasive agricultural pests in the world. This species affects crops such as maize, rice, sorghum, and cotton, with confirmed presence across the Americas, Africa, Asia, and Europe.
Spodoptera frugiperda can attack hundreds of plant species and cause significant agricultural production loss. Currently, pest control heavily relies on chemical pesticides. Although effective in the short term, these methods can harm the soil, water, pollinators, and human health. In addition, the insects can quickly become resistant to insecticides, making traditional methods less effective and more expensive.
With this scenario in mind, light traps are a sustainable alternative because they use the natural behavior of nocturnal insects. However, most farmers still rely on handcrafted traps made from plastic bottles or simply soap and water containers, which are low-cost and easily accessible options, but with some limitations. So, what if we took this concept and transformed it from a basic tool into a more sophisticated system? That's where our solution comes in. Our project is an automated solar-powered light trap that monitors environmental conditions and captures Spodoptera using UVA light and an automatic capture system. The system is designed for autonomous operation. Through an RTC, it manages activation and deactivation cycles based on a configurable schedule. At night hours, the light source turns on to attract the target insect. Once it enters a capture zone, an IR sensor detects its presence and triggers a pusher fan, securing the insect into a collection chamber. On the other hand, its network architecture is dual. Locally, it allows users to connect any device to configure time windows, adjust ventilation runtimes, and calibrate the sensor's triggers. Remotely, it connects to Wi-Fi networks to transmit data directly to an IoT dashboard, enabling monitoring from anywhere in the world.
Now, let me break down the circuit components and their respective roles. The Myosa motherboard serves as the central control hub of the system, enabling both local and Wi-Fi connectivity.
The IR sensor tracks insect movement, and once a specific count threshold is reached, it triggers the fan for capture.
The BMP sensor records temperature and atmospheric pressure in real time.
The RTC maintains the date and time, enabling the device to enforce time windows and systematically structure log data.
The TF card module stores data into folders on a micro SD card and hosts the HTML dashboard for local access and configuration. The OLED display provides real-time information directly in the fields, including environmental variables, global status, and operational windows.
Finally, the power stage uses a buck converter, optocouplers, and IRF MOSFETs to control the load.
With this modern light trap concept, we see to demonstrate many four capabilities: autonomous operation, sensor-based automated capture, real-time remote monitoring via IoT, integration of environmental variables to evaluate and optimize system performance.
This project aims to reduce the reliance on chemical pesticides and promote more sustainable control methods for agriculture. In addition, the system collects valuable data to support future decisions in integrated pest management. Finally, we also want to express our gratitude for Myosa and their development kit, whose plug-and-play capabilities allow us to connect and test hardware easily.